Well, so this integral is not easy. There are a few ways of doing it, and somebody use Fourier series. Some are using the Cauchy residues, contour integration, and so on. Now here I want to use my method. I want to share with you. I'm consider this integral. Consider the integral x to the power of t minus 1 over 1 plus x squared dx. Well, this integral is convergent as long as t is less than 2. Now, then I'm using substitution. Let u be x squared. So x is equal to u to the half power. Dx is equal to half u negative half d, right? Yeah, that's obvious. So my integral becomes 1 plus u. Yeah, this is u to the half t minus 1, huh? And d. No, I forget this. Half u to the negative half d. Sorry, dx is this. Now then I combine this with that. I take 1/2 out. And this combined with this one, it becomes u to the half t minus 1. Yeah. And d. Okay. If I replace half t by p, p is half t, then my integral becomes 1/2 integral 1 plus u, and the u p minus 1, right? du. Yeah. Well, then I'm using beta function. This is equal to 1/2 beta p and 1 minus p. Let's recall the beta function. The beta function is this, right? Beta z1 and z2 is integral 1 plus t z1 plus z2. Z is a complex number, and t to the z1 minus 1 dt. Yeah. Well, if z1 is equal to p, z2 is equal to 1 minus p, then this integral becomes t to the p minus 1. This 1 plus t. z1 plus z2 is equal to 1. Yeah, and then dt, right? Yeah, this is what we want. And also we know that this one is equal to beta p and 1 minus p, which is reflection. So this is equal to gamma p and gamma 1 minus p. This is gamma, this plus this, right, is equal to 1. Yeah. So okay, this one is equal to pi half sine pi p. Yeah, that is my beta function. So here, so my integral is equal to 1/2 sine pi p. Yeah. Now my p is what? P is half t, right? My p is half t. So this is equal to pi half sine half pi t. Well, okay, good. Okay, in other words, this is equal to this is equal to that, equal to this, equal to this, equal to this, which means that my integral x to the t minus 1 plus x squared dx is equal to pi over 2 sine half t pi, right? Pi t, same thing. Then I differentiate both sides with respect to t. Differentiate both sides of the equation with respect to t. So this side, this is a constant, so no change. This will be t, x is constant, times the log x. Yeah, that's right. That side, one of the sign is a cosecant. So pi over 2, the derivative of the cosecant with respect to t. So this will be negative cosecant t pi over 2 cotangent t pi over 2, right? Multiplied by the chain rule, pi over 2. Okay? Chain rule. Now we're taking differentiation. We're taking derivative with respect to t, so half pi is constant. All right. So this one is equal to negative quarter pi square cosecant t pi over 2 cotangent t pi over 2. All right. This is my derivative of this with derivative of this with respect to t, that is this. So this is equal to that. Then we take this derivative with respect to t again, this one and that one. This one, take a derivative with respect to t, so x is a constant, 1 plus x squared, x t minus 1 log x squared, right? Because the derivative of derivative of x to the power of t minus 1 is x, is x times t minus 1 times log x. Yeah, okay. That side derivative with respect to t. So is equal to minus, that's constant. Now this derivative with respect to t, we're using product rule. So this one derivative times this plus this derivative times this. Now this derivative with respect to t is a negative cosecant t pi over 2 times this one, so it makes cotangent square t pi over 2 minus this derivative times this one is a cosecant q t pi over 2, right? Then, or they are together times pi over 2 because the chain rule. Okay, chain rule times this one derivative, which is pi over 2. So this one is equal to, take negative out, become positive. This one times this one is 8, and pi q. And this will be cosecant t pi over 2 times cotangent t pi over 2 plus, because negative is taken out, cosecant cube t pi over 2. Yeah, okay, good. And my target integral is this integral when t equal to 1. So, yeah, so my target integral is this integral when t equal to 1, right? So we just replace t equal to 1 here, is a q cosecant t equal to 1, right? Cosecant half pi is 1. Cotangent half pi is 0. Square. Sorry, square. And plus cosecant cube. This is 1 cube. So it's end up with pi cube over 8. Yeah, that is my result. So my I is equal to pi cube over 8. Because my I is when t equals to 1. This is my I. Okay, I think this is a good method. Thank you.